Ever since black holes were identified in the 1970s, they've been one of the most intriguing phenomena in space. Even though we can't actually see them, people have long been fascinated with how they're formed and how much they affect anything that comes into their path. Black holes are huge. By huge, we mean seriously huge. To give you an idea, black holes can be 10 times the size of our sun. And how big is the sun? Well, the sun is more than 100 times bigger than Earth. Basically, black holes are massive. There are also many of them out there, millions, in fact. How many? It's thought that the Milky Way alone can contain something like 100 million black holes of varying sizes. And if you think that's a large number to get your head around, try this. The Milky Way is home to an enormous black hole known as Sagittarius A. NASA calculates that it's roughly 4 million times the size of the Sun, and some 26,000 light-years away from Earth. So what exactly are black holes, and how are they formed? To put it simply, black holes are formed when huge stars self-implode, causing them to collapse under their own weight. These stars reach the end of their life and run out of energy. They simply finish up in a massive explosion called a supernova and then implode. The radiation from its nuclear reaction keeps these stars fully blown, and when this runs out, gravity causes the star's core to collapse. What used to be a huge star is reduced to a tiny spot that we can't see. As a result, black holes take up no space. However, and this is what makes them fascinating, they do contain mass. It's the very same mass from which used to be stars, and it's what gives them their immense gravity. What's more, black holes grow, getting bigger and bigger. The more matter they consume, the bigger they get. This is because a black hole's gravity pull is so strong that it sucks up anything that comes into its path. This could be planets, stars, dust, debris, and even other black holes. And all lovers of sci-fi will know that a spaceship that's lost its bearings can be zapped into a black hole, from which there is no return. A black hole's incredibly powerful gravitational pull creates a kind of point of no return, as its boundaries are known as an event horizon. And the gravitational pull is so immense because black holes have mass amounts of, well, mass packed into a tiny speck. The tidal pull exerted on nearby objects is the same effect that creates the Earth's tides. A black hole's gravitational pull on the side of the object that is closest to it is much stronger than the pull on the opposite side. This makes the gravity stretch the object and pull it apart, in a process called spaghettification, or the noodle effect. Any object passing through the threshold of the event horizon into the black hole sucking zone is stretched vertically and compressed horizontally, not unlike a spaghetti noodle. How would this work if a human or a spacecraft was unlucky enough to be sucked into a black hole? The good news is that it would be over very quickly, less than a second, in fact. Nothing can escape the pulling force of a black hole, and that includes light. That's right, the fastest element in the universe is powerless against black holes, which is why they're so called. Black holes suck up any light, making them impossible to see. However, we know they exist because of the effect that they have on any objects or matter surrounding them. Once something is hoovered up into a black hole, it can't come back. It may be emitted into different forms, such as particles, gas, or dusts, but ending up in a black hole is pretty much the end of the road. Some have debated whether black holes could be linked to another universe. However, this is strictly confined to the realms of science fiction. Although technically such shortcuts or wormholes to other universes are possible, it's fairly likely that anything traveling via such a wormhole would just collapse. But the idea of some kind of extreme gravitational force that's been tossed around as far back as the late 18th century. In 1783, a British scientist hypothesized that invisible forces that could consume other matter most likely existed throughout space. John Michael argued that even if these entities couldn't be seen, it could be proven if a star was found to be orbiting them. In 1915, Einstein used his theory of relativity to predict the existence of black holes that were too powerful for even the speed of light. It wasn't until 1971, though, that astronomers were finally able to detect evidence of black holes, even without being able to actually see them. British astronomers detected an invisible object orbiting around a blue star over 6,000 light-years away. They were able to spot it due to the massive radiation waves being emitted from it. This object was named Cygnus X1 and is generally thought of to be the first officially spotted black hole. Scientists have broken down black holes into 4 categories. These are miniature, stellar, intermediate, and supermassive. Stellar black holes are the most common, typically being 10 times larger than our Sun. And then we have supermassive black holes, which can be anything from millions to even billion times bigger than the Sun. It's been estimated that approximately 1 in 1,000 stars has the potential to become a black hole. The nearest black hole to Earth is a stellar mass black hole named Gaia BH1, which lies about 1,600 light-years away. Which brings the question, could a black hole swallow up the Earth if it got close enough? The short answer is not likely. A black hole would have to be extremely close for Earth for this to happen, and the chances of that are remote. Even if a black hole were to consume our Sun, Earth would continue on its current orbital patterns, although things would get very dark and much colder. So what does the future hold for black holes? Will they continue to grow in size and number? Current observations would suggest this is indeed the case. NASA scientists have predicted that the universe will continue to expand perpetually. As this happens, some stars will get bigger and bigger before imploding and becoming black holes. Other stars reach the end of their lifespan and simply explode, shedding their outer layers and forming into what we call a white dwarf. A white dwarf is simply the swirling combination of helium, carbon, and oxygen. If the universe continues to expand, it leaves black holes with ample time to keep consuming more and more matter and objects. As for whether black holes will eventually consume the entire universe, sure, but it would take more than 1 trillion years, which is 100 times the age of the universe itself. So in our lifetime, not plausible. And note that I said plausible. Can't say anything's impossible, right?